Stop sharing. Good. So any function we look at, we have to understand the pattern. What does this function say? This function says that it's applied to whatever, and it requires us to multiply 4 by that whatever, and then subtract 3. So understanding the pattern, at this point, I can evaluate the function for anything that the function is defined at. What type of function is this? And what would be its domain?
The domain is all real numbers.
Perfect. And why? What type of function is it?
Linear?
Yes, it is a linear function. Thank you very much. Do we all agree with this, everyone? Okay. So if I'm asked to find f of 4, I have 4 here, 4 times 4 minus 3. If I'm asked to find f of k, I have 4 times k minus 3, and so on and so forth. The same idea here. So what we're going to do, I'm going to share my screen. Grab your calculators if you have a calculator available. And here is what we're going to do. In y equals, right here at the top, remove, clear anything else that you have in there, and enter this function as 4x minus 3. Then make sure that you go to second and table set. And again, make sure that the independent variable, only the independent variable is in the ask mode. Scroll down, click on highlight ask, and press enter. Make sure that this is highlighted. After that, go to second and table. And punch in all the numbers that we have. We have 5.1. Enter. We have 5.01. Enter. We have 5.001. We have 5. We have 4. We have 3. We have -2, and the rest we cannot put in the calculator. So now I'm going to make sure that I see the entire number. Who knows how many digits I'm asked to write. So let's go back up. Go to the y variable with the right arrow and go up. So obviously this is indeed 17.4. This is 17.04. There are no other digits that are hidden. This is the entire number. So I can copy them in the table. So I have 17.4, I have 17.04, 17.004, and then 17. And for f of 4, I have 13. For f of 4, of 3, I have 9, of course, and then -2, -11. Now for the others, I would perform the same steps, but I cannot use the calculator. Meaning, I think that the hub was the problem, with my camera. Okay, so I entered 17.4, 17.04, and so on and so forth, 13, 9, -11. Here, this is k. All I have to write is 4k minus 3. Here I have 1 plus t. So I have 4 parentheses because it's a sum. It's a binomial. 1 plus t and then minus 3. I have to distribute. I get 4 plus 4t minus 3. And when I write in descending order, I have to start with a degree. The degree is 1. So 4t, and 4 minus 3 is positive 1. Finally, I repeat the process. This piece is x plus h, and this piece is x plus h. Exactly what I did with all of them. So I will write 4 quantity because it's a sum or difference. I have to write it in parentheses. Now distribute. And there is nothing else I can perform here. This has to stay as is. Now, if I go back to any of these, will you give me an ordered pair? What is the ordered pair, let's say, for this And what would be the ordered pair for this?
4, 13.
Very good. X is always first, and Y is always second. Excellent. X comma Y. Or basically, X comma f of X. When X is 4, f of 4 is 13. Okay, can anyone else give me this ordered pair?
K, 4K minus 3.
Thank you. Good. Perfect. So that's all we had to work on 19. Let's move on. Let me go back to sharing. And where is the book? Where is my book? Here it is. Sorry, guys, you're always in the way. I'm kidding. Okay. Now, I would like to talk about something like this before we move on. So I need to do some explaining before we choose a different type of problem. So I'm going to stop sharing and talk about something that is maybe about 50% of this course. And that is called the difference quotient. And yes, it has to be memorized. When we get to it, then we finally understand what it means, etc., etc. Okay, here's a function. I have to shift a few things here. And if I push my computer further away, I may lose you for a second. No, no, awesome. I didn't lose you. Great, perfect. Okay, so here's a function for us. So let's say this is f of x, and I have here point P, and I have here point Q. These points are on the graph of the function. This has coordinate x. The x coordinate is x. And for this one, for Q, the x coordinate is x plus a little bit. So h is a small number. Maybe like 0.1, 0.3, 0.01, something like that, a small number, which immediately says that Q and P are far from each other or close to each other, to one another.
They're close.
Very close. But I have to zoom in because I need to explain something. If I show you that this is point P and this is point Q, then how will I show anything? Right? So assuming that we are zooming in, they're very close, but zooming in makes them appear at a distance from each other. But they are really very close. This is a very small number, this little h. So if this is 5, this is 5.1. If this is 5, this could be 5.03. So they're very close to each other. Now, can anyone give us the y-coordinates? The y-coordinate for P and the y-coordinate for Q.
Say the y-coordinate for P is just y, and the y-coordinate for Q is y plus another small number.
No. You are right about y, but I don't want y. There is another way. Y is correct.
Is this one of the examples where you just plug in whatever you want for y?
No.
No? Okay.
No. So if this is x and the point is on the function, what could be the y value here? We just wrote it. This is a
F of x.
Exactly. This is a super important concept to understand. If a point is on a graph of a function, if x is whatever, the y-coordinate must be f of that whatever. This is carved in stone. So obviously, thank you. So this must be f of x. Now, can anyone give us the y-coordinate for q?
F of x plus h.
That's it. Awesome. Does everyone understand this? Is that a yes? Okay. Now I'm going to draw a line. It's called the secant line. Nothing to do with trigonometry. Secant line PQ. Why is it called secant? It's because it crosses the graph of a function in more than one point. In this case, in 2 points. There is also something called tangent. How will a tangent line, let's say, at P look like? It will look like this. This is the tangent at P. It touches the graph only in 1 point. But a secant line crosses the graph in 2 points or more. But the tangent line touches the graph in 1 point. So if you want to illustrate it better here, it's something like this. Okay, so we also have the tangent line at P. I'm going to focus on the secant line for a moment, not on the tangent line right now. So let's focus on the secant line. The secant line is the line that passes through these 2 points. Anyone remembers how to determine the slope of this line? Any line passing through 2 points?
Is it rise over run?
Excellent. Who said that?
Kirsten.
Thank you. So now, can anyone remind us what is the formula for rise over run?
So y equals mx plus b.
We're talking about the slope.
Oh, it's y2 minus y1 over x2 minus x1.
Very good. Awesome. We have 2 points. Before we continue and find the slope of this line, let's write down in our notes what is the meaning of the rise over run. So the slope represents the rate of change of f of x with respect to y. I'm sorry, of course, f of x with respect to x. What does it mean? It means that between these 2 points, there is a rise and there is a run. But because it's a line, between any 2 points, we will find the same rise and run because we're talking about the line, right? The line has a constant slope. So the rate of change of f of x with respect to x, that's what it means. Of course, I can continue here. I can write between these 2 points P and Q, but I haven't gotten to that yet. We will write it in a minute again. So then, the slope of the line PQ now, keeping in mind the formula for the slope, will be. Who can give us that slope? Ready, when you are. Anyone?
F of x plus h minus f of x over x plus h minus x.
That's it. Was it Nick?
Yep.
Excellent. Of course, the positive x with the negative x will go away. So this is f of x plus h minus f of x divided by h. And this is what we call the difference quotient, which is the slope of the line PQ, which is the rate of change of f of x between, there is a W in here, and E-E-N, between P and Q.
Professor, what is the symbol that you're using for slope? Is that an M?
Always.
M, okay.
Yes. Lowercase m. Yes.
Okay, thank you.
Thank you.